AudioMicro.com.
My video will be on how torque converter works.
AudioMicro.com.
Torque converter is seen as the most complicated part in the vehicle today. It is very important to automatic transmission.
AudioMicro.com.
They only found in automatic transmission. Torque converter has three functions: transmit power, engine to transmission; 2, it drives the front pump of the transmission; 3, double engine torque output.
AudioMicro.com. AudioMicro.com.
Torque converter is mounted to
AudioMicro.com.
a housing and it's mounted to the engine. The first part is the impeller. It has curved
AudioMicro.com.
blades and it's full with fluid. When the impeller spins, the fluid will be flowing outward.
AudioMicro.com.
That is how the torque works.
AudioMicro.com. AudioMicro.com. AudioMicro.com.
Real direct fluid to the inner part of the torque converter that is called the stator.
AudioMicro.com. AudioMicro.com.
Stator has
AudioMicro.com.
curved blades at about 90 degrees in angle, which in result multiplies torque. The fluid flows back more slowly.
AudioMicro.com.
Located between a car's engine and its transmission is a torque converter, which is connected to the engine through a drive plate. The torque converter is a crucial component of the drivetrain. It amplifies engine torque and transfers it to the automatic transmission. A torque converter consists of 3 vaned wheels. The torque converter is filled with automatic transmission fluid from the transmission. Engine power is transmitted to the transmission via this oil. Power from the engine is first transmitted to the torque converter's front cover. Integrally connected to the front cover is a vaned wheel called an impeller, which the transmitted power causes to revolve. The impeller blades make the oil revolve. The oil is pushed outward at high speed by the engine torque. This oil pushes against another vaned wheel called a turbine, making it revolve. Drive power is transmitted from the turbine through the input shaft to the transmission. Typically, this drive torque is not enough to briskly accelerate a vehicle from a complete stop. The solution to this is the addition of a component called a stator or reactor. The stator functions to smoothly return the oil from the turbine back to the impeller without any power loss. When the vehicle first starts moving, the oil flowing through the turbine next flows through the stator and is returned to the impeller flowing in the same rotational direction, amplifying the power used to turn the turbine. As the vehicle accelerates and the speed of the turbine increases, the stator becomes a resistance that makes the oil flow less efficiently, dissipating power. For this reason, a one-way clutch is built into the stator. As the speed of the turbine increases, the stator revolves without creating any resistance. Some transmission loss is unavoidable in a torque converter that uses oil to transmit drive power. To reduce loss, a damper-equipped lockup clutch is used to enable direct connection. The damper-equipped lockup clutch is installed between the front cover and the engine side of the turbine and moves in the axial direction in accordance with changes in oil pressure. A change in oil pressure presses the damper-equipped lockup clutch against the front cover. Through this action, the drive power transmitted to the front cover is directly transferred from the damper-equipped lockup clutch to the transmission via the turbine. But because the engine and transmission are directly connected, fluctuations in the engine's rotational speed are also transmitted to the transmission. This causes the drivetrain to generate vibration and resultant noise. A spring built into the damper-equipped lockup clutch absorbs the vibration so it is not transmitted to the transmission. Today, the growing number of front-engine, front-wheel drive vehicles which have a transversal powertrain layout has generated demand for elliptical-type torque converters because they take up less space in the axial direction. The recent trend toward 5- and 6-speed automatic transmissions has created a need for super-elliptical torque converters that take up even less axial space to allow more space for the transmission. This is a cross-section of a torque converter. This is where the oil revolves. Oil flows more easily when the torque converter is round. With an elliptical torque converter, the flow is not as smooth, reducing torque converter performance. Exedy is now developing a high-performance, compact elliptical torque converter that offers extremely smooth oil flow. Research is now underway to determine how to achieve smooth oil flow despite the difficulties presented by an elliptical shape. As a torque converter revolves at high speed and its blades are three-dimensional, it is extremely difficult to examine the oil flow inside. Extensive experimentation has provided Exedy with a wealth of data on the oil flow inside a torque converter. We also utilize a method called PIV to measure the oil flow inside a torque converter. This method employs a transparent torque converter and special particles in the oil, which are illuminated by laser to visualize the oil flow. Previous experimental methods yielded only inferred values for oil flow. Visualization using the PIV method provides data that is much more precise. Utilizing the huge volume of data obtained through this cutting-edge technology, together with advanced simulation technology, Exedy is able to develop high-efficiency, high-performance torque converters much more quickly. Computer programs that simulate fuel economy and acceleration performance enable Exedy to design converters that perfectly match a vehicle's requirements. Exedy is also utilizing these technologies to develop a very compact starting device consisting of a torque converter that incorporates a high-performance damper. Offering performance and quality to satisfy requirements around the world. Exedy will continue meeting the challenge as drivetrain specialists, powering the further evolution of the automobile and today's motorized society. Excellent and dynamic. Exedy. A torque converter consists of 3 vaned wheels. The torque converter is filled with automatic transmission fluid from the transmission. Engine power is transmitted to the transmission via this oil. Power from the engine is first transmitted to the torque converter's front cover. Integrally connected to the front cover is a vaned wheel called an impeller, which the transmitted power causes to revolve. The impeller blades make the oil revolve. The oil is pushed outward at high speed by the engine torque. This oil pushes against another vaned wheel called a turbine, making it revolve. Drive power is transmitted from the turbine through the input shaft to the transmission.